Hello, hello population. Today we're doing another challenge. Are you excited? Okay, so I'm learning OpenGL. I decided to try and learn how OpenGL works and all. And I'm reading this. Oops, what the fuck, I messed my shit up. Hold on. Okay. So I'm reading this interesting documentation. I mean documentation guide, you could say. If you go home, it's kind of a book, you could say, in HTML, and you can read. And I was like, okay, let's go read it. And we're reading Hello Triangle, the hello world of OpenGL, you could say. So okay, I downloaded the source code from their GitHub. It's you just type this. What the fuck? You type this site github.com, and you will find the code for that's being used. That's for the examples in the book. So what I'm doing now, if we the fuck, I closed it. The hell? No. Okay, I closed it, I guess. So if you go inside of projects, gl build, make. So if we compile it and build it, and then run the first program, you can see it. It's a triangle. It just makes a triangle. In the example, there was no chain animation for changing the background or whatever. I kind of scripted it my own to see if it works. It's just adding another function into the display function, which displays the stuff, and say to redisplay it to recall the function on each frame, I guess. Call to update the display. Yeah, you should call after all of your rendering to display what you rendered. Okay, if you need continuous updates of the screen, call this at the end of the function. Yeah, that's it. So now what we want, I was like, okay, it's perfect time to make another challenge. And in this challenge I will be doing rotation, of course. It's just a simple challenge to apply, maybe some kind of rotation to this, using the very famous rotation matrix, boys and girls. Rotation matrix. There's this Wikipedia page. I also linked it in the donut.c video, or at least my on my blog. It's a pretty useful page. You go just here and to the three dimensions, or in 2 dimensions. You go into the basic rotations, and here you have the rotations for the 3 dimensions. If we go back, here should be the rotation in the 2 dimensions, I guess. So let's just find it real quick. For example, when the vector is rotated by an angle, its coordinates are, I guess that's it. Yeah, because we're gonna rotate it in, yeah, a counterclockwise rotation of a vector through angle theta. The vector initially aligned at the x-axis. Yeah, okay, no shit. The standard rotation matrix has the following form, and we're just gonna apply that to the program. So what I'm gonna do is go here, and it's not gonna be pretty code. It's gonna be some random garbage. Just me trying to finish the challenge as soon as possible, as fast as possible. So if we make a float, let's call it angle. I mean, actually theta to make it more clear. 0, and float theta updater 0.00, I don't know, 04. Okay. If we go at the beginning of the program, I'm gonna include the math.h library. So now if I try to build it, it's probably not gonna run, because never mind, it did run. Okay, Okay, cool. So now if I go here, I will have to calculate the new position for the vertices, for the vertex. So if we move it down, actually, what is this called? What is this being called? That's what I'm interested in. It's being called inside of initialize vertex buffer, which is a problem because I want to update this goddamn thing. Well, in theory, we could just let's see, how will we do this? GL bind buffer. We're gonna bind the position buffer object, which is gonna be this. It's gonna bind, okay, the vertex positions is gonna, I mean, put in the data. So I guess we can do a little test to see what this will do. Like if we can actually update all of this. I mean the values for the triangle. So like let's set a new updater. Let's call it J, whatever. It's not really, yeah. Let's just call it J. J updater 0.0. I don't know. 0.1. Okay. And here, if J will be higher or equal to 1, or if J will be lower or equal to 0, we will set the J updater to J updater. It's negative form, of course. So now if we go here, we will update. We will update the position. No, I don't know. Update a random position. Okay, so now if we go here and say like vertex positions 0. Yeah, let's go with the 0. Except what happens if I, for example, put this one to 0 for now, just to see. Okay. Let's try and build it. I mean, let's see. Okay, now we have this. So if I set it, what happens if I set it to 1? This is X, so it should be there. Yeah, it's moved here. Okay, it should be on the right. Yeah. So if I apply an animation, it should, this point should go from here to here, something like that, over some period of time. So if we go here and say, okay, vertex positions plus equals, except this is a const, so this is not gonna work. Fuck. What happens? Yeah, if I remove it. Okay, and now apply J updater. Doesn't work. How should this be done? Vertex positions 0 plus equals. We're just gonna, yeah, okay. What if we try and, I don't know, how do you debug? I mean, how do you log something? OpenGL log debug log. Okay. God damn this internet, bro. I'm loving it. Debug opposite that makes debugging optimizing. What if I go here? Debug. Message callback. Oh, it's the site is okay. Never mind, that's up. Okay. How do I debug message insert user messages? Okay. While most debug out messages are generated by the open, it's possible to generate messages from outside of the implementation. Those messages are generated by the following command. Okay. Oh lord. Yeah, okay, fuck it. I mean, let's try it. GL debug message insert. The source, which is something. Wait, let me try and insert. Yeah. Okay, so insert an application supplied message into the debug message queue. The source of the debug message to insert. That tells me a lot. Okay, message to the debug output queue. Application debug. Application type I guess it's just this one. I'm guessing. Okay. Then we have the type of the debug message to insert. It's a I don't know. Let's say this one. An error, but it's not actually an error. Okay. The severity, let's just set it to this, not this. What the fuck? The fuck, bro? Okay, severity low, yeah. Then, so we have type ID. What the hell do I do with the ID? Type ID. The user specified identifier of the message insert. I don't know. 0, lol. ID is available for application defined use and maybe any value. This value will be recorded. Okay, yeah, it can be probably 0. It's okay. So severity, okay, length of the string contained in character arrays. Let's say 10, and I'm going to output the, I don't know, debug message. Wait, this is a const char message, yeah, okay. So const char message, and if I do what to do here? Okay, let's see, we have to output the first vertex, I mean the first element of the vertex positions array. So if I do, let's just say first element for now. Can I do this? Plus, I don't know, plus vertex positions. 0. Message, okay. Make. It's a float. Yeah, indeed. Okay, how to convert a float to, convert float to char plus, char pointer, C. We're doing in, yeah, we're doing in CPP, okay. C++. STD, okay, stream. Char pointer. sprintf. Microsoft, this is on Microsoft. The fuck, bro? Yeah. No, thank you. What was that website? Very useful. CPP reference, I think. Yeah, okay. The documentation, yeah, okay. Language. Float. theory, yeah, okay, as printf, it could work. As printf. The function in the printf family produces coordinated. Okay, yeah, just tell me about the as printf right away, please. As printf. Listen to the line codes such as the following. Yeah, okay, this can work. Except on which STO, okay. STO, we imported it already, it's perfect. Okay, let me just do this. Char debug message. I'm not gonna do anything, okay. And as printf message. The F vertex positions 0. Something along those lines, I'm guessing. Okay, fair, yeah. Has to be a character pointer. That should be it. Documentation fault core dumped. Why exactly? Oh my god. Can we just try with printf? That would be so much faster, I guess. Debug message. If I try printf the first element. F, okay, and vertex positions first one. Why building it 2 times? Okay, makes sense. It's gonna be equal to 1, yeah, okay, it's gonna put it, okay. In theory it does work, this code does work, except we have to recall it. Recall the initialize vertex buffer. Cause like, initialize vertex buffer. Where is this called from? Initial, oh my god. Oh yeah, instead of the init. Fuck. OpenGL display initialize vertex buffer. Can we recall it by any chance? Like by going actually here and like typing I don't fucking know, initialize vertex buffer, okay. If that works, bruh, imagine. Oh my god. Oh, that actually works. That actually fucking works. Except, well, kind of. If J is... What? Wait, let me try to... Is smaller or equal to 0. Let me try and remove this. In theory that works, yeah. Okay, if it's higher or equal to 1, or if J is smaller or equal to 0.0f. Let's say it that way. Make and run. The fuck? Why does this happen? The first element, okay, and then put it to... Just, let me try and output this. Hold on. Printf J. What? Oh shit, I'm stupid. We have to fucking update it, bro. Oh my god. Wait, hold on, we have to go down here. Yeah, we have to update it, okay. J plus equals J updated. The hell. I forgot to update it. Okay, now it should work. What the fuck is this kind of? Well, that works, yeah, kind of. You could say. It moves it, so that's nice. If I add another 0, it's gonna be 10 times. It should be 10 times slower. Yeah, that works. Okay. Except, why is it above 1? The first element. It shouldn't be above 1. We said that if... Oh yeah, no, if it's... Yeah... Not if J is above 1, if... if the vertex positions that like that. Okay. Yeah. This is what I had in mind. To move it from here to here, yeah. Not from here to here. That makes sense. It goes from 0 to 1, which is what we wanted. Now the next thing that we have to do is like update this code so that it actually rotates the triangle in some kind of way, which is pretty easy in my opinion. You just have to like use the rotation matrices. Yeah. Okay, let's do it. So the first thing that we have to do, I'm not sure if this is the best code. Actually, let me try to remove this. Maybe we don't need it. Yeah, we actually don't need it. I'm not sure if this is the correct way of doing it, to like just move the function down in the display function, but for now it works, so I don't mind. We have to multiply it with a rotation matrix. So let's just define it real quick. Actually, yeah, let's define it. Float rotation matrix. Actually, we cannot define it over here. We have to go down here, remove the theta, go up here and define the theta here. Float theta updater 0.004. Now we remove the J because it's fucking useless, and here we have to define the rotation matrix. And how it's going to work, you may ask. Let's see. Cosinus theta negative sinus theta sinus theta and yeah, cosinus theta. Okay, cosinus theta. This is our rotation matrix. Now remove those and rotate the points using the defined rotation matrix. Okay. We need the angle of every point of the vertex. So if here, if we define the vertices, I think that's a correct way of typing it. I don't know, it's 3. Actually, you could just simplify to points. Okay, points. And x position, which would be the first one, and y position 1, and then z position to 2. Okay, and the last one we don't need to bother for now. Okay, so now if we have to loop through them. So for int I equals 0, I will is when while it's less than the points I plus plus. So now we loop through this, through each point. This is a point, this is a point, this is a point. And yeah, we just take the we have to just take the first and the second and the third, like attributes, I'm calling them. Each point has 4 attributes, so one x, y, z, and the last one x, y, z, and the last one x, y, z, and the last one. So now we simply do like int, actually not int, float x, and it will be I multiplied with point attribute plus x position. It should be something like that, if I'm not mistaken. I point attribute plus y position float z I multiplied with point attribute plus z position. So z, yeah, 1, 2, yeah, okay. And now what we just have to do is update them, update the points, update the values, the core values, and actually, yeah, calculate and update. Okay, to update and write to the array, we're just simply gonna do float new x, float new y, float new z, and we are going to vertex position 0, not 0, x, new x, y, new y, positions z, new z. Okay. Yeah, okay, now fetch the values, float fetch, I don't know, yeah, I call it fetch x, vertex positions x, fy, vertex positions y, float fz, vertex positions z. Okay. Now, okay, yeah, here we calculate them with the rotation matrix. We multiply them. So how are we gonna multiply? It's pretty simple. This one we're not even gonna multiply, to be fair. We're just gonna leave it as 0.0 because we're working in 2 dimensions in this case. Remember, we are working in 2 dimensions for now. If I wanted, we could have done like with 3 dimensions as well. Maybe we're gonna at the end of the video, but for now let's just work with 2 dimensions. So we have to calculate the x and the new x and y, we have to multiply them each with the matrix here. So how we multiply them? Well, simply take the x, okay, fx multiplied with cosinus, okay. The rotation matrix 0 plus the y multiplied with the rotation matrix 1. And I'm gonna go here and just kind of rotate the rotation matrix. Sin theta to make this easier to write. Okay. This apparent, a much better way of writing it inside of C++, you could say. At least in this case, because you have cosinus, sinus, minus sinus, and cosinus. Yeah, okay. Now, to calculate the y, we have fx rotation matrix 2 plus the y times rotation matrix 3. Nothing more than that. Maybe just add the brackets, because brackets. Okay. Now, after updating the values, I think that's it actually. We just have to go up here and tell it to update the theta. Theta updater. Okay. Rotation matrix, we have it. Rotate the points, we have it. Calculate, yeah. Update, yeah. That should be it, I'm hoping. Not yet, not yet. Make, let's see, worst problem, minus sinus, expected identifier token before. Excuse me? Is it because arrays are with the curly brackets, of course. Fuck me. Okay. Expect primary expression before. God damn it. Okay. That's right, it has to be an array. Expected. Oh god damn, bro. God damn it, C++, bro. Oh, that's lovely. More errors. Float. Let's see where on line 138. Okay. Invalid types float. Yeah, the vertex positions right here. Well, let's try and output them for now. Vertex positions Y, vertex positions Z. Fuck. C++ get element from array with, I don't know, index, yeah. Yeah, that's how it's done. The fuck? Vertex positions. Valid types for array subscript. Okay. You cannot use a float in an array subscript. The fuck is an array? Okay, first of all, what is an array subscript? Array subscript. C++. 1, 2, 4, 5, 6, 8, 9, 10. Yeah, it's correct. Oh my god. Okay, fuck you. Now I see what was the problem. So yeah, and you cannot get an index with a float, goddammit, Kevin. Nice. It disappeared, bro. The fuck? Oh yeah, maybe because it's a... can we try and initialize it just once now? Let's see what that will happen, and that's gonna break everything. Make... Yeah, it already broke everything. God damn it. Let's see. Comment this. Go up here. Let's see. Let me try doing this, and also if data... No. I don't know. What can the problem be to you? I have no idea. What happens if I try to rescale this? Nothing, to be fair. Yeah, no, just... yeah. Concentration. Rotation matrix. Am I missing the... Hold on. X, Y, and Z. If I go down here, X will be multiplied with this plus the Y. Oh, now I see. F. Okay. Damn, bro. Kinda spinning a lot. Okay. Let's try to lower the speed. It's still kind of fast. Lower it by 10 again. Still getting fast though. Okay. It works, guys. God damn. Oh lord. Yeah, it works. I made it. I made it. It's kind of dying. It's going a little too fast, in my opinion. I would have to, let's see. Yeah, because over every. Yeah. Okay. Now I see. Now I see what's the problem. The problem is there's no need for a theta updater. Just theta is gonna be, in this case, the time, the angle by which we're gonna rotate the triangle. So like if I set it now to, I don't know, 0.01, it's gonna remain static, or at least it should. Oops. And now it remains static, or at least it should, if it doesn't speed up now. Yeah, okay, of course. And yeah, it works. That thing works. Now, another challenge. Let's try to make it 3D. In this case, I don't know. I don't know how I will make that. Because, yeah, never mind. It's always in OpenGL. Everything is in 3D the whole time. So let's try to add some 3D-ness to this shape, I guess. Okay. Now, multiplying with a 3D rotation matrix, it's still pretty simple. All you have to do is, yeah, you have some basic rotations. Let's say we want to rotate it around the y-axis, which is rotating it like this. If this is a cube in front of us, it's gonna rotate like this. If this is the y-axis, it's gonna rotate like this, yeah, or like this. So this is the matrix given. We just have to update it to the rotation matrix, and here we're gonna do, actually, let me just comment it out and remake it float rotation matrix. Okay. Now, cosinus theta 0 and minus sinus, negative sinus theta. Okay, and now 0, 1, 0, because the y always stays the same. And then the sinus for the theta 0 and cosinus for the theta. Okay. Now going down here, we're gonna update all of those values to something, to the value that we get by multiplying it. So fx multiplied with the rotation matrix 0 plus fy multiplied with the rotation matrix 1 plus the fz multiplied with the rotation matrix 2. And same story with the rest of the rest for the other two, except it's just one column down. So you have 3 plus fy rotation matrix 2 3 4 and the fz times the rotation matrix 5, and here fx rotation matrix 6, fy rotation matrix 7, and plus the fz rotation matrix all in all, it's 9. So yeah, okay, perfect. Now, if we try to run this, it's not gonna work because why exactly? Rotation matrix. Feeling like we fucked up somewhere here. Yeah, we did. Okay. Dot 0 1. And ladies and gentlemen, the thing works. I'm seeing somewhat of a goddamn paper triangle. I thought it was gonna be more more thicker because I added some kind of like. Actually, no, it shouldn't be. Yeah, it shouldn't be actually, because if you take a look at at here, it's going it's going through. But all in all, yeah, it shouldn't be thicker. It should just be thin, because it's still a triangle, of course. God damn it. To make it thicker, we would have to make an actual 3D shape. In this case, the triangle is not a 3D shape, so you cannot make a 3D triangle, except by putting it inside of a 3D space, which is what we've just done. Yeah. Okay, I like it. I like it. Now, if we want to extend this and add multiple rotations, like let's say around the Y as well as X, you would just take those values and replace them inside of a new rotation matrix for the 0x. Let's say we declare another one and multiply. Use those values inside of the those values in the multiplication formula for the new x, y, and z values, and then just write them to the array. And yeah, that's the challenge I was given today, by myself. Jeez, let's go. Oh goddamn, C++.